Hello, this is the lesson for the surface area of pyramids. So we're going to continue along learning surface area. This is actually the last surface area lesson that we will have before we finish up and do volume. So the first thing that I want you to think about for surface area of pyramids, since we have been focusing on prisms so far, I guess is how they're different. So what shapes are we accounting for? So for a pyramid, what is the base? How many bases are there? And what shape are the sides? Here is our pyramid. So I would like you to take a look at this. First of all, like I said, let's talk about the base of a pyramid. The first thing to note with a pyramid is that there's only one base. So in this example that I've, cheaply just kind of highlighted over, we have one base, and depending on your pyramid, that base could be a triangle, it could be a square, it could be a hexagon, etc. But you're only going to have one base as compared to a prism where we had two bases. And this will be reflected in the formulas that we actually end up using for the surface area of a pyramid. You're going to see the fact that there's only one base reflected in that formula. The other thing that you're going to notice has to do with the shape of the sides. So when we were finding lateral area for a prism, we were finding the lateral area basically for a shape that was in the shape of a rectangle. However, with a pyramid, our sides are a different shape. As you can see here, the sides of a pyramid are always triangles. So when we go in to make the formula for the entire, lateral area combined with the base to make the surface area, you're going to see that the formula reflects that triangular shape, and we'll kind of talk about that in just a little bit. So there are our triangle sides. Today's objective might look pretty familiar to you because we are still chipping away at this 7GB6 where we are working with, mathematical problems involving pretty much everything that has to do with geometry. So 2 and 3D, today will be 3D objects composed of triangles, quadrilaterals, polygons, cubes, right prisms, surface area. So these are all the points that we're hitting with this lesson. One thing that's going to be significantly different from the lessons I've been teaching lately is I've really been stressing altitude lately, but when it comes to the pyramid and its surface area, we are only taking the area of the outside of the pyramid, so we will not be using this altitude. This is a no-no. This is not what we're using. I'm going to switch it up on you and really probably confuse you, but we're going to have to start getting used to it. When we are studying surface area of a pyramid, we're going to be using the slant height, which is this yellow one. And it's represented with a little symbol that looks like an L, like a cursive L. For the surface area, so you're going to fill in surface area of a pyramid. This is the only situation really that you need to use this, but you need to use the slant height, which is represented, like I said, with this cursive L letter, in order to find the area of the lateral faces. So this is only used when we want to figure out, what is the area of this face over here, even though it's at a slant, what is the area of this? So this is the only time you're going to use that slant height. It's very rare that we actually use it. But like I said, don't confuse it with the altitude because this is going to be the height of a face, not the height of the actual pyramid, which is what we know as the altitude. So we're using slant height, super, super, super confusing, and I want to make sure that we don't, just kind of breeze through this because this really is important, but we're using this slant height just while we're doing surface area for pyramid. I want to go on and talk about the formulas. As promised, I told you that we're going to see some differences because of the fact that we only have one base and because of the fact that we have triangular sides. So in order to find the lateral area of the pyramid, it's going to be similar to finding that of the prism. But instead, we're still going to do perimeter, but instead of doing just times the height, we're going to do 1/2 of the height, because if you're familiar with the formula of a triangle, it's 1/2 base times height. A triangle's half of a rectangle. So our formula looks like this. 1/2 our perimeter times our slant height. So perimeter being the perimeter of the base of your pyramid. So over here in this little image, my base goes around the bottom, my perimeter. So how far is it to go all the way around, this pyramid? And then the height, though, is, like I said, going to be replaced by this slant height, because we don't really want to know the height of the pyramid. We want to know how tall those triangles on the side are. So we're going to be multiplying it by the slant height, which goes from vertex to the edge of each triangle at the base. So that is this L right here. And then we're going to be multiplying the whole thing by 1/2 or divided by 2, because these are triangles and not full out rectangles. So that is where we kind of derive that lateral area of a pyramid from. And then in order to figure out the full surface area, all that you're left with to find is the area of the one base that's left. In this one, we only have one base. Looking over here at the net, you'll see we don't have two. We just have this one right here in the center. So the surface area is going to be that lateral area that you initially found, and you're just going to add the area of the base, the capital B meaning the area of the base. So let's go ahead and try an example. So the first example that I have says, we're going to find the surface area of the square pyramid. Pretty important to note that it says square, meaning that this base of the pyramid is a square. If they had only given us one of these dimensions, 25, just one of them, we should have been able to assume that the other side was also 25. All four are, because it's a square. So we're going to use our first step, which is to find the lateral area. So our formula to find lateral area is 1/2 of our perimeter of the perimeter of our base times the slant height of our pyramid. So let's go ahead and start with the perimeter. So like I said just a minute ago, the base is a square. In order to find perimeter, it's basically like if you're going to put a fence around it. So how far is it to go from one point all the way around it and get back? So we're going to do 25 plus 25, that's 50, plus 25, that's 75, plus another 25, that's 100. So our perimeter equals 100. I like that. It's a nice round, even number. It'll make it easy to work with. Next thing we need to do is figure out what our L is, our slant height. And remember, slant height is always going to be on that diagonal where we're looking at, what's the length from the vertex down to the base on each triangle. So my slant height is right here, and it says that it's 32, which is simple. So I'm just going to do 32. So now I've got my P and my L, P and L. So 100 times 32 is just going to be 3,200. But I still have one thing left to do on my formula, which is to take a half of that. So 1/2 of 3,200. So half of 3,200 equals 1,600. And these are in feet, so it's going to be square feet. So this is what our lateral area equals. Our lateral area is 1,600 square feet. So I can just go ahead and move that over. Our lateral area we now know is 1,600. And in order to find the surface area, the only thing left to calculate is the area of the base. So we just need to now, instead of doing perimeter, find the area of this square. In order to find the area of the square, we would just need to do base times height, because the square is also a rectangle, so base times height. And you'll notice 25 feet and 25 feet. So we're just going to multiply 25 times 25. There we go. So if we multiply 25 times 25, we're going to get 625. So this is our B, and this is our LA, our lateral area. So now we can just substitute those in and we can do our addition. We have 1,600 plus 625 square feet. So altogether that is going to equal 2,225 square feet. And we're finished because that's our LA and our B. So that's your answer. Let's go ahead and try one more. I'm going to give you a little guidance, but not as much guidance as I had on this one. And in this example, I know some people like to have an image and some people don't need one. I'm a visual learner, as you guys have probably all figured out. So I will go ahead and do the picture just for those of you who like it. But a pyramid has a square base. It makes it easy because we just did one with a square base. But it has a square base, and I'm going to attempt to make a somewhat decent pyramid with a square base. Not that great, but okay. And it says that this is 20 for each side, and that it has a slant height. So from the vertex down the side of the triangle, the slant height is actually only 8 feet. So it's not really drawn to scale whatsoever. But this is kind of what our pyramid looks like. So of course the first step whenever we're going to figure out the surface area is to find the lateral area, which means finding the area of all the triangles that make up the sides of the pyramid.